forget to like and subscribe this channel.
Assalamualaikum. Hi everyone, it's me again. I'm Madam Nurul Hidayah binti Kamadin and I'm going to teach you chapter 5. In this chapter, you are going to learn the beauty of gas, liquid and solid. Okay, let's start. For chapter 5, the topic is states of matter. There are 4 subtopics in this chapter, which is gas, liquid, solids and phase diagram. Now we are going to study 5.1, which is gas. For the learning outcome for this video, you should be able to explain the basic assumption of kinetic molecular theory of gases for an ideal gas. There are 3 states of matter, which is solid, liquid, and gas. So we can clearly see the main difference between each state is the arrangement of particles. Now let's look at properties of gas. There are 6 properties of gas, which is shape, volume, compressibility, density, flow, and miscibility. So today we have a bottle of chlorine gas. For the first one, which is shape, the shape of gas follow the shape of container, and the volume of gas will equal to the volume of container. Next, look at the compressibility. Is it easily compressed or hard to compress? So gas can be easily compressed, so it is highly compressible. Now let's look at density of gas. So we all know that gas has very low density. Next, let's look at flow. So we all know that gas can flow more freely. And the last one, gas is easily miscible among each other when they are put in the same container. Now let's look at kinetic molecular theory of gases. So, kinetic molecular theory is a model to explain the behavior of gaseous particles and is based on extensive observation of the behavior of gases. If the gas follow all the postulates of the kinetic molecular theory, then the gas is called ideal gas. There are 4 basic assumptions in kinetic molecular theory. The first one, volume of gas molecules are negligible compared to the volume of its container, meaning that the volume of gas is equal to the volume of container. Next, the intermolecular forces between gas molecules are negligible. It means that we can ignore the intermolecular force between all gas molecules. The next one, collision between gas molecules are perfectly elastic, meaning that when gas molecules collide among each other, there are no energy loss between them. And the last one, the average kinetic energy of molecule is proportional to the absolute temperature. It means that when we increase the temperature of gas, the kinetic energy of gas particle will also increase. Let's look at let's look at the first one. So the volume of gas is equal to the volume of container. Let's say we have 1 liter of gas. So let's say we have 1 liter of container. So it means that we also have 1 liter of gas. The next one, the intermolecular force. So for ideal gas, we can ignore that there is. So for ideal gas, we can assume that the intermolecular force between each gas particle is negligible. The next one, elastic collision, meaning that when gas molecules collide among each other, there is no heat loss during the collision. The next one, when temperature increase, the kinetic energy of gas particle will also increase. There are 4 parameters that we can use to describe gas, which is quantity, also known as mole, the volume of gas, the temperature, and also the pressure. So, what is meant by pressure of gas? So, actually, when gas collide with the wall of container, it will exert pressure onto the wall of container. So this is what we call as gas pressure. So the SI unit for gas pressure is Pascal, which is equal to 1 nm negative 2. So 1 atm is equal to 760 millimole mercury or 760 torr, and it is also equal to 101325 Pascal and also equals to 101325 nm negative 2. So you should know how to convert the pressure into SI unit. One, if we have 750 millimole mercury, how do we convert into atm? So let's look at this together. So 760 millimole mercury is equal to 1 atm. So if we have 740 millimole mercury, so how do you want to solve this type of question? So mathematically, you will divide 740 with 760 times 1. Then you will get the answer. So the answer here is 0.9737 atm. Now let's look at example 2. If we have 100,000 and m negative 2, and how do you convert this into atm? So from the constant value, we know that 100, 1, 325, and m negative 2 is equal to 1 atm. So if we have 100,000, so just divide 100,000 with 101325 and times 1. Then you will get the answer in atm. The answer is 0.9869 atm. So that's all for part 1.